WIKISPEED, Lynnwood, Washington, August 9th, 2016. I'm here in the shop with Senna Justice and Jackson Rudd. Jackson, can you walk me through what you've just rocked?
Cool. So, hi. What I'm doing is I'm trying to make it so that our car, which we hope to make autonomous soon, can recognize lanes so that it can stay in them. The first thing I wrote was a program that uses a Q transform to take an image and draw two lines on it, which represent the lanes. The problem with this, and why I don't think that we should stick with this method, is though it's very cool and you can get very quick results with not a lot of code, that is the Q transform method, it only does lines, and in reality for any sort of like urban or mechanical application, there's curvy lines. So unless you're on the freeway, this is kind of a bummer. So the second thing that I'm working on...
That's called lane rec, right?
This
and
is
can
lane
you
rec.
put that code in the GitHub so people can muck with it?
Totally.
Yeah.
Yes. And so the second thing that I'm doing is I decided, okay, so we should probably, maybe a better strategy would be to find a way to see where the lane markers are so that we could do a curve fitting method. Whereas like, okay, so this is a lane, this is a lane, this is a lane, this curve fits it well. In order to do that, you could write a very, very kind of challenging application that goes through all the different types of markers, the little liney markers, the whole line markers, the little dot markers, there's a curve and that's not a marker, but you should know not to go on the curb, da-da-da-da-da. That's for other interns and maybe some sort of other software online to do, or maybe me over the course of an entire year. But since we're trying to do quick wins, what I've decided to do is hack it, and these will be our little lanes and these little green things. And I wrote a program here, I call it Find Green, that takes my picture. Oh my gosh, no.
So the idea is this is all pre-processing for the autonomous guidance system. First, if it has any image of lanes, and Jackson has tried this with many different pictures of lanes, it'll find the straights, but doesn't yet find curves. Now, because there's many, and so that's pre-processing already. Straight lines can go directly to the autonomous driving algorithm and say, okay, stay between these lines, and that way it's much simpler. Now, the second is, these are green lane markers, is the idea. So this can be set up in a factory setting.
So what it does is, here's our little lane marker,
So
and
those
it drew
yellow
little
target.
3 circles around it. Every horizontal line will only have one data point. The circles will never intersect, so we don't get data points that are too close together. And these are sort of randomly distributed around the lane, but that's fine because after 3 or 4 data points, any sort of polynomial regression will be able to get rid of that noise.
And find the curve or find the straight.
Exactly. So, and maybe there's a little bit more tweaking to do, but in general, it does the basic thing of every horizontal, it looks for one, and it doesn't let two intersect with each other, 2 big circles.
Excellent. Let's do this demo here, and then we'll do how you regressed the accelerator pedal as round 2.